Hey there! Today, section 7.4's pre-algebra scales, like used in maps or modeling and stuff. But we're going to make the circle, obey the circle. Make the circle, obey the circle. Make the circle, obey the circle. Sometimes you make the table and you obey the table. Sometimes you make table, obey the table. But today, we're making the circle, obey the circle. Give me the camera, Grandma. All right. So what time is it, Grandma?
Time to get to work. Crack that whip.
So I'm just gonna do the. See, now they're making your proportions. Here you go. Thinking proportionally. Remember, thinking proportionally is always multiplying, dividing horizontally or vertically. A proportion is when a fraction equals a fraction. All right. Anyways, I'm going to do your skill check. So here. So let's make sure vocab. Scale. It's a ratio. A scale is a ratio, and a ratio is just a fraction. So if 1 inch was 10 feet, that's actually here's the model, and then here's the actual. Is actually 120 times bigger. So it's 1/20th. 1/120th of the actual size. So you just say like model and real in my circle, or inches and feet. Anyways, you'll see. So, here we go. So first one here, find the distance between towns. So here's your towns. And so number 1, I'm gonna make my circle, and my scale is centimeters and kilometers. I'm doing centimeters on top and kilometers on the bottom. Now I'm going to get ready to obey the circle. So I write my blank check there, which is a fraction equal to a fraction. And if I look here, it says 1 centimeter is 15 miles. So 1 centimeter represents 15 kilometers, sorry. So then here, 3 centimeters. So where's the 3 go? Well, centimeters are on top. So here's my x. So there's my let statement. X stands for kilometers. Can I think proportionally? Yes. This is times 3, so this is times 3. So x equals 45 what? 45 what? Kilometers, which would be the actual distance. All right. There's number 1. Number 2. So 5.2 kilometers. So again, make the circle. I'm doing centimeters over kilometers. And I made my circle. Now I'm gonna obey my circle. The scale is 1 centimeter is 15 kilometers. And so the scale gives you the circle, and it gives you half your proportion. So the 5.2 centimeters goes on top. And I'm trying to find the actual distance. I'm just gonna crisscross. So x equals, and I already multiplied. Oh, I can do this in my head. 75 plus 3, it's gonna be 78 kilometers is the actual distance. All right. I'm not gonna do number 3. It's the same way there. Oh, here's number 3 worked out. I did the math, all right? But same thing, 190.5 kilometers. Okay, number 4 here. So how far is it from big city to Allen? Here's big city, and here's Allen. It's 4 centimeters on the map. So number 4, I'm gonna make my circle. It's centimeters over kilometers. And now I'm gonna obey my circle. My scale is 1 centimeter is 15 kilometers. See, when I do my circle, my unit's over here. Now, all I have is 3 numbers and a variable. You know, I don't want to have my units in here. I just make my circle over here. And so 4 centimeters from big city to Allen is 4. So the centimeters are on top. So the 4 goes on top. Here's my x. I can go times 4 times 4. I can crisscross. Either way, x equals 60 kilometers. And that's how far is it from big city to Den. And then number 5, or big city to Allen. Now Danville to Allen is 3.4 centimeters. So again, I'll just set it up. Centimeters to kilometers. It's 1 to 15 and 3.4 to x. And again, just crisscross. X equals 45. Anyways, number 4. 15 times 3.4, 0, 20 carry the 2, that's 6, 45, so 51. So it's 51 kilometers. Right. Oh, wait. I forgot, this scale is different. Here the scale is 2 centimeters is 25 kilometers. I'm using the wrong scale here for 4 and 5. Oops. So, Grandpa made a mistake here. So centimeters to kilometers. You gotta read carefully here. So the scale was 2 centimeters, 25 kilometers. So 2 is 25, and so 4. Oh, well, that's gonna be friendly. That's just times 2 times 2. I'll do my little arrow, times 2 times 2. That's called thinking proportionally, which is always multiplying or dividing horizontally or vertically. So there's number 4. Number 4 is 50 kilometers. And then number 5, centimeters over kilometers. It's gonna be 2 over 25, and this time it's 3.4, and here's your x, and so 2x equals 75 plus 10 would be 85, and half of 85 is 42 and a half kilometers, right? So there's that. Okay. And now for skill set number 2 here. So what's the distance on the map? Here's your scale. Here, 1 inch is 30 miles. So this is on page 283. So make your circle, inches over miles. One inch is 30 miles. And so 75 miles. Miles go on the bottom. And I'm just gonna crisscross. 30x equals 75. And I'll divide by 30. Well, if I just divide by 3, 25 or 75 divided by 3 is 25. So 75 divided by 30 is going to be 2.5. I can just use my head and figure that out. Inches. So that's what it's going to be on the map. Anyways, that's how you do those. Here I'll show. Here's number 2, and again, dividing by 7.5, would just, rather than 2.5, it would be 0.25 inches. And number 3, you have inches over feet. Your scale is 6.5 inches over 26 feet. Well, that's 1 inch is how many feet? I was going to do it 6.5, but I just made it 6.5 because you'll see in a second here. So I crisscross, so 6.5x equals 26. I divide by 6.5, which is, then I made it improper, 13.5. So 26 divided by 13.5 is 26 over 1 times 2 over 13. 26 is 2 times 13. The 13's cancel. You just end up with 2 times 2 is 4. So anyways, 1 inch goes to 4 feet. On the map, every inch counts for 4 feet. So there's that one. Right? And the last set of problems here. What setting would be used to make a table appear 4.5 inches wide? Well, now problem with this is which one's width? Is this length and width, or is this width and length? I said this was the width, because usually the length is the long one. And so, maybe this would be faster if I just show you. I already worked these out. So I called this length and width, just to be clear. So here's where I went new over original, when it's like this. So if the original was, if it was 3 inches wide, and it's gonna be, and the new one's gonna be 4.5 inches wide, well, your percent always goes over 100. And so now I crisscross, divide. So it was an enlargement, because it was, if it's over 100%, it's gonna get bigger. If it's under 100%, it's gonna get smaller. So expansion or enlargement, when it's over 100%. Okay. Number 2, what is the length? So the length was 4 inches. So again, new over original, make your circle, obey your circle. And now we know that it's the percent's 150%. So this is just divide by 25, divide by 25. There's 6 quarters in a buck and a half. And so the new length would be 6 inches. Number 3, give the dimensions of the table in exercise 1 if the photocopier was 75%. So here's the width and the length. New over original. Okay, I'm trying to find the new one. The original was 3. 75 goes over 100. And I don't see anything. I'm going to just crisscross. I could reduce that, but anyways, I crisscross. And 225 divided by 100 is just 2.25 inches wide. And then here's still new over old. The new, I don't know, the original was 4 inches, and this is divided by 25. So the new one's going to be 3 inches long. All right. And then the last one, you have a scale, and it's 1 to 72. So the real thing is 72 times bigger than the model. So if the model is 9 1/3 inches long, how many feet is the actual plane? So I want model over actual. So the model is a scale is 1 to 72. Just use words here, what words you want to use, but try to just make them fit the problem. So 9 1/3, I called that 28 thirds. And here I'm trying to find the actual, I crisscross. And 72 times 28 over 3, that's 3 times 24, the 3's cancel. 24 times 28 is 672, and 672 divided by 12 is 56. So it's 56 feet long, actually, right? I guess this is easier just to go with what I already had worked out. So anyways, that's how I did. So make the circle, obey the circle. Put in the circle whatever makes sense to you, and that helps you to write your proportion. Remember, what's a proportion? It's when a fraction equals a fraction.